was told that I have 8 minutes, so I don't think I'm going to be able to get through everything. But it's and it's on auto timer too, I think. Not sure how to shut that off.
Red is backwards and green is
okay. So I'm going to talk about the Pacific Island Blue Carbon Knowledge Exchange Network, or PIBLUX. It's called PIBLUX because I'm horrible at coming up with clever acronyms. And what this is it's a peer-to-peer group where Pacific Islanders are working together to assess carbon stocks. And which is the forward button? The green? Nope. Other green, okay. And I'm going to, so the reason why I came up with this idea 2 years ago to create this network, because there were, and there still are, several parallel activities occurring across the Pacific that are doing the same thing, and there's not a lot of cooperation, or just like people aren't aware of what's going on. So for example, I was in Fiji a couple years ago. I was invited to do a mangrove workshop, and as I left the hotel, there was another group coming in to do the exact same workshop we had just done. And we were unaware of this. So I thought it would be great to have this network to coordinate efforts where we could pool resources for a more strategic assessment of blue carbon ecosystems at the national level. So again, there are several workshops that are happening. There are some that we had led in the past where we would show up, we would collect a little bit of data, but it wasn't really, I mean, it was valuable, but not enough to really get it over the finish line, right? So countries need national level data to participate in carbon markets, to include in their national reports, their national communications, and the workshops that we were doing just were generating a fraction of that data. So this is an opportunity for us to work together to do wall-to-wall assessments in a country. And this is important if we, I'm going to back up here. So back in 2010, this was a swamp project that we led. Dr. Sahadev Sharma and I came up with this idea. Instead of just coming up and doing a few plot measurements with the country, we set up a grid across the country and did a wall-to-wall assessment. We created our very first Blue Carbon Dream Team who worked with us, and we basically set out and we measured the carbon in all of the mangroves of Cambodia. And one of the things that we discovered was that as you go from north to south, we saw about a 5-fold reduction in carbon stocks. So if you just show up and you do a few plots here and there, you're going to miss this, and you're going to either overestimate or underestimate the carbon for that country. So it's really important to do these wall-to-wall assessments. And I'd like to mention too that this pattern is driven by the soils. So if we had done remote sensing and tried to use the biomass models, it still would have been inaccurate, because most of the carbon is in the soils, and this pattern was due to changes we saw in the soils. We did something similarly in Palau, where we did a national assessment, another wall-to-wall assessment, and here what we would do is we'd pull up by boat and we take a transect through the mangrove. Every 75 meters we set up a plot. So we have about 20 of these transects around the island of Babeldob, which is the majority of Palau, and that's where I'm based right now, is in Palau. And what we discovered is as we walked from the ocean towards the mangrove interior, biomass dropped by 150 meters from the ocean. It stayed very low until we reached about 500 meters from the ocean, where it increased. And what we discovered is, because of this national assessment, that there's a band of dwarf mangroves that completely circumnavigates, that's not the right word. Anyway, there's a belt of mangroves that is surrounding Palau. And again, if we just come in and sampled the edge or the interior, which is usually the easiest places to access, we would have overestimated the carbon stocks for this country. And also from a scientific perspective, this is really cool. Like, what is causing this? We don't know. It's like a sandwich of dwarf mangroves. So I invite anybody to come to Palau, and I'll show you this. So again, with that sort of as the setup, we created this knowledge exchange network. And I thought this would be really great to share here with IPBC. I actually pitched this a few years ago when we were starting this idea as a potential like boots on the ground component where we could collect the data that we need to participate in these carbon markets, the discussions we had earlier today. And I'm pleased to announce that we actually launched it officially in April. So we're testing this out. We brought a group of Fijians and Samoans to Palau, and this is the first blue carbon dream team. Actually, Cambodia was the first. This is the second. The team showed up and they spent 2 weeks where we trained them how to use remote sensing to map the aerial extent of mangroves and seagrasses, and then they learned how to quantify the carbon stocks of those ecosystems. And so what we did is we sliced Palau up into 5 different regions, and we assigned each region to a team. And then those teams used worldview image. We had access to worldview too. And basically, in a nutshell, each pixel in worldview has a unique spectral signature. And you can use that spectral signature to identify, or you can correlate that to the habitat that that pixel represents. So for example, you have this near-infrared band here. Upland forests and mangroves have distinct spectral signatures. So the teams went through and basically created polygons in ArcPro of known habitats, open ocean, mangrove forest, seagrass, and created this like coarse map of seagrass. This is at the and mangroves at the national level. And then we went out into the field, we ground truthed it, we visually like verified what the habitat type was, brought that back, and we improved the map. And I'm not going to go through this, but this was the end result. So after 2 weeks of working with this team, Palau now has an aerial estimate of how much seagrass they have, 177 square kilometers. So this is a number they can take to the bank. They can use this in their next up-and-coming greenhouse gas assessment. We got it across the finish line. We have numbers that they can use. Unfortunately, I don't have carbon stock data yet because we're still waiting for the lab results. But as the team went out, what worked? Oh, this is an old version. We went out, we used the BCI methodology for seagrass assessment. So when they verified what the habitat type was, we also sampled above and below ground biomass for the seagrass. We collected soil cores and brought them back, processed them, and they're being analyzed in the lab. So what worked with this? Well, first of all, we created an effective blue carbon dream team. I think this was the most effective part of this campaign, is that they worked together, they solved problems, because this was not easy. I don't know if anyone's ever tried to do a remote sensing exercise, but we hit snags all along the 2-week period. They worked together, they came up with solutions, and were able to come up with, again, an aerial estimate and figured out how to sample the seagrass around the country. We generated aerial estimates and carbon stocks for mangroves from this exercise, and we also did that for seagrass, although we're still waiting to get the carbon data. And the other great thing about this is that we now have a trained team, and we'd like to bring them to Samoa next year to do the same national assessment. So Samoa has blue carbon data for their seagrasses and their mangroves, and then in 2026 we want to come to Fiji. So I'm hoping we can talk more about that with some of the Fiji crew to see how we can make that happen. So how much time do I have? I have lots of time? I have 1 minute? I think I'm going to, well, I missed the seagrass workshop. I'm going to just say one thing. I missed the seagrass workshop, so maybe you guys already talked about this. But one of the biggest issues that we realized was that, you know, seagrass occurs across a variety of densities, right? So you have low to medium to high level densities. And when if you just simply map the seagrass, you're going to overestimate the carbon stocks, because not all seagrass is the same. And so we realized this was one of the challenges we encountered, and when we went out to ground truth the map, we started to write down what was the percent cover. So we would lay down a quadrat, and we were, as you can see here, and then we would record whether it was low, medium, or dense. And then Laurel Gutenberg, who's the remote sensor, was able to create maps like this, right? So this is the worldview image, and then she was able to create this map where she stratified by density. And maybe that's something everybody's doing in the seagrass world. I'm a mangrove ecologist, so I don't know. But I think this is something that we need to consider when we are doing future mapping efforts of seagrass. I think I'm going to stop. I'm going to stop right there because I think I'm out of time. But please come and talk to me if you're interested in learning more about PyBlueX. And also I have stickers, so. Thank you.